There. Thank you for clicking on this video on composition of functions. This video is going to focus on the mechanics of how we do the operation of composing functions together. Please give this video a like if you find it helpful, subscribe to the channel for more math help, drop a comment or question to engage, and please check out the practice set for this lesson. It's not usually enough just to watch somebody else do problems. You need to actually get on the bicycle yourself, so to speak, and try to do them. So the practice set is linked in the description box and will be linked at the end of the lesson as well. I wanted to start with a quick review of what we've already covered with composition. Now, if you're jumping in on this lesson, I am going to ask that you see the first video on composition for a look at the why behind it. I'll go ahead and I'll link that video up here in the upper right for you. But that video poses a scenario that gives you an idea of why this is an operation that we care about and what we can accomplish by performing composition. Now, the symbol for composition is an open circle. Okay, and so it looks something like this, where function f and function g are the functions that we are going to be composing together, and the symbol for that is a little open circle. Now, we want to be really careful about this, and I mentioned this in the previous video, that we do not confuse that with this, because this is multiplication. Okay, and that is a different operation with a different video in this playlist about how to carry out multiplication of functions. So make sure that you're not confusing the open circle with the closed circle. They are two different symbols here. Now, what does it mean when you see that composition symbol? A lot of my students do trip up over this because in all of the other operations, you pretty much use the operator, that would be the adding, subtracting, multiplying, or dividing symbol, the way that you're used to using them, and you just plug in function f and function g in place of the letters f and g and then carry out the operation. Composition is a little bit different because you're not putting the two functions, say, side by side or on top of each other in the visual layout. You're plugging one function into another function. So that f of g of x means this. So instead of a simple f of x, you're going to take that second function and plug that in every place that you see an x. Okay, so it can get kind of messy, as we are going to look at in a moment. All right, and so the last thing on this slide is the purpose. The purpose is to combine two functions into one function that will basically carry out both functions in one fell swoop. Okay, it's generally an efficiency step. If you want to look at that again, I've got that link, or did have the link. You probably have to rewind the video. Rewind? Do we rewind video? We go backwards? I don't know. I'm like old, so I think of like hitting a rewind button. But go back in the video to find that link. I'll also try to remember to link that in the description box as well, so you can see like the functionality of this. Okay, so all of that being done, how do we do this? So we're going to look at it with equations, equations, tables, and graphs. Those are the main ways that we represent functions. Composition with equations is a very, very common one. If I had to narrow this down and say I'm only going to teach it one way, like my students, one thing, we got limited time, this is probably how I would opt doing it. Okay, so a couple things, so let's go and carry this out. So we've got, now I did not mean to do that exactly, but now it's there, so there you go. We're going to do f of g of x on this side. Now, here's what I recommend for my students to do, because when I learned this, when I was taking Algebra 2, I was very into like the procedure of it and would do the composition backwards. So I couldn't remember if f of g, like of x, was that g plugged into f or f plugged into g. Like I just felt like I'm getting this backwards. So what I tell my students to do is this in terms of procedures, okay? Whatever function is listed first, that's what you're going to start with. So if f is listed first, start by writing down whatever function f is. So in this case, it is 2x squared plus 3x minus 1. Now, when I present this in class, I will sometimes do this, okay? And I'll take the time to do it here, okay? And you can probably see what I'm doing. This is not an algebra step. This is a teaching instructional step where all I've done there is I've highlighted the x in green to make it kind of pop out when we look at it. Now, what we're going to do is take function g, which in this case is x minus 3, and I am going to substitute every x with an x minus 3. And for this step here, I am going to retain the change in color so that you can see a little bit better what I'm doing. So the 2 is going to stay there. And then instead of x, I'm going to plug in x minus 3, and instead of x being squared, it's going to be an x minus 3 being squared. And then we have another x over here, and this will also have an x minus 3. And now once you've done that, technically you have done the composition. Okay, composition is that process of plugging one function into another, and I have done that at this point. We have taken out the x and we have plugged that x minus 3 in. From this point on, it is generally an order of operations festival of simplifying that so that we can like kind of make it into the most convenient form possible. The most common mistake here is students trying to distribute that squaring through the parentheses. That will not work. That's an order of operations issue. So when you go to do this, you need to remember that is going to be x minus 3 times x minus 3. And right here, I'm going to go ahead and do the distribution now. Okay, so that's going to be 3x minus 9, and I'll bring down the minus 1. You can multiply that x minus 3 times x minus 3 any way you want. You can distribute the 2 through one of the parentheses. Just make sure if you are going to distribute the 2, it does only go into one of those parentheses. If you try to distribute the 2 over both, you're going to end up with an extra factor of 2. So you can do this with foiling. You can use the area model, which is what I have taught on this channel. And let's go ahead and combine these two down here. The minus 9 and minus 1 will give us minus 10. And now I'll distribute the 2 through. Okay, and then we have a little bit of combining like terms going on. If you see it, we have a negative 12x squared plus a 3x squared, and we also have a plus 18 minus 10 in terms of combining like terms. So our final result will be 2x squared minus 9x, and then 18 minus 10 is 8. And so that is my final function, the composition of functions f and g together, where we plug g into f. So that was fun. Typically in an Algebra 2 class, you probably wouldn't see anything more complicated than that, though you could. Anybody can give you any kind of functions that they want and say, here, go ahead and compose these together. So, but that's a pretty good level for like what's it likely that you would see on a test. Now, on the other side here, we're going to go ahead and do g of f. So we're going to compose them in the other direction. Now, going back to what I usually tell my students in terms of setting up a procedure that will work here, whatever that first function is, so in this case, it's a g, you're going to start by copying that down. You are not going to write out function g and then function f and put that little open circle in between them. That's usually how I know that my students have not watched a video or a lesson on this, that they were not paying attention when I demonstrated it, because I never do that in class. Now, using the same little technique, I'm going to highlight the X in a different color. just to draw our attention to it. That's it. And now everywhere that I have that x, I am going to plug in the other function, which in this case is f. So that'll be 2x squared plus 3x minus 1. And then we have the minus 3. And the parentheses here end up being simply cosmetic. That's another expression that I've used on this channel a lot. It means that they're not serving any mathematical purpose. They're just there to separate one function from another. So we can go ahead and just combine those like terms down at the end. Minus 1 minus 3 is minus 4. And so that's all we have going on here. Now, what I kind of brought up on the screen a little bit too early was notice that f of g of x, that's the fog, does not equal g of f of x. That's our GOF. Okay, that's our very informal way of saying this. Don't confuse that with actual math vocabulary, fog and GOF, although people will know what you mean. That doesn't look like a nice open circle. So after pontificating on that, there we go. They are not the same. Okay, we do not land with the same function, and that the difficulty can vary. So you can have composition that is a real mess algebraically, and you can have composition that is very, very straightforward. So you don't want to see a composition problem and automatically assume that it's going to be very difficult or very hard or very easy. And the other is watch out for that order of operations. Specifically, that is calling your attention to this right here, where like you don't want to say, oh, that's x squared minus 9, because it is not x squared minus 9. So just pay mind to that. All right, now composition with equations. This, I apologize for it being so small. If you were given a number, then there's two ways to do this. So we're going to be using the same two functions here. Okay, so we are using f of x is equal to 2x squared plus 3x minus 1, and g of x is equal to x minus 3. So instead of being asked, like, what is fog or GOF, or what is f of g of x or g of f of x, suppose you have a number. So you're asked, like, what is f of g of 6? Okay, now there are two ways you can do this. Which way is the better way for you depends 100% on your personal preference and what else you are asked for. So the first way you can do it is you can use composition to find f of g of x. So this is a generic function that's going to have an x in it. It's not going to be specific to an individual number, and then plug in the 6. So we found on the previous slide that f of g of x was equal to 2x squared minus 9x plus 8. Please back up the video if you want a refresher on that. Now that we have a function for f of g, now we can take that 6 and plug that in. So f of g of 6, we would plug the 6 into that function, and we land at f of g of 6 is equal to 26. Now, this is probably the best way to do it if you have already found the composed function or the result there. So if you already have f of g of x. But if you recall, that process was kind of a mess. So if you have not already found it and don't need to find it, then you might be better off with method 2, which is this. Find g of 6. So when you're looking at f of g of 6, what you've got in the middle there, okay, is this. G of 6. So you can go ahead and find g of 6. That's a pretty simple calculation. That is right here. So g of 6 is just 6 minus 3, or 3. Okay. And now instead of having f of g of 6, you now know that g of 6 was equal to 3. Just found that right there. Okay. G of x is equal to 3. So now find f of 3. So that becomes a much simpler problem of plugging in the 3, and you'll notice that we land at the 26. So both of these land us at, whoops, that is not what I wanted to do. there we go, land us at the 26. So this one does involve the dual calculations, which we talked about in the previous video. But I also mentioned in the previous video that the idea behind composition is that we're kind of creating this shortcut for ourselves. If you only have to do the calculation one time, it is often not worth the bother of going through the algebra to find the shortcut. So that is up to you. Both of those ways are completely valid ways of doing the composition when you are given a specific number. And that brings us to composition with tables. So here we have a table. This was generated from a Desmos. I put in my two functions and then had Desmos generate the tables. And when you're dealing with a table, you will be given a specific value. And so we're actually going to approach this the way we did on the previous slide, with like doing it in stages. So f of g of 2, now you could also see that as this. I'll make sure that I have like a color you can see up. F of g of -2. I'm sorry, I think I said 2 a second ago. It's a -2. So you could see it presented like that. And our strategy for this is going to be to start by finding g of -2. Well, here's my x values, and we have a typo. I like missed the negative sign. So I'm gonna have to pivot unless I want to like redo this whole slide. So let's pivot, and because that is not correct. So that slide is not helpful. Oh, this is a terrible table, like bad enough that like I wanted a 0 there. All right, so pivot, let's see, let's do f of g of 2. Okay, because I got a plane to catch tomorrow morning, and I'm not gonna, and an oil change appointment for my car in not that long from now. So we're not gonna redo this. This is an example of pivoting, and if you would like to criticize me in the comments, just make it constructive, okay? Don't. All right, so g of 2. So we're going to start with this g of 2 and literally go to the table and find out, well, what is that? So that would be plugging in a 2 for x, and then I just come over here and I see, look at that. So g of 2 is -1. So my problem then, instead of f of g of 2, I could say that is f of -1. And now go back over here to the table and find -1. And this time I'm going to be looking for f, and I see that that is -2. Ta-da! And so that is how you would do this with the table. Now, if I had put together this table correctly, we could do the next one. But there you go. I file this under videos that at some point I will want to re-record. But let's take a look at this, and we'll carry it as far as we can. So we have g of f of 1. And so what we would do is start that with f of 1. And we would go to our table, and we would find x is 1, and then get the 4 from that. So g of f of 1 is equal to 4. And so now the problem, instead of g of f of 1, becomes g of 4. Now, in the interest of like being problem solvers instead of, beating ourselves up, g of f of 4 would be off the end of the table. So if we look at our pattern over here, let's see if we can find the pattern. And our best chance of finding the pattern here is going to be right in this chunk right here, where I can see that g of x is counting up by ones. So I'm going -2, -1, 0. And I think I can confirm that if I count backwards, this would be -3, which means the -4 makes sense. And this would be -5, which means the -6 makes sense. And so we can use our pattern problem solving to figure this out, which means if that pattern continues, then the value on the table there would be a 1. So g of 4 would be equal to 1. Ta-da! My sincerest apologies for the mess that I have made of this slide. It's just a reminder that there is a human on the other end of this video. In the interest of turning everything into the best learning opportunity that you can, that extension of the table and recognizing that unless somebody has gone totally random on you, that there is a pattern, there's a pattern there to exploit because our functions do not do random things. So in the event that you're taking an exam and somebody has messed up the question, it does not render you utterly powerless. And we could probably find the pattern for f as well. Looking at it, it does appear that the pattern could be quadratic of some sort. And the reason why I say that is because it starts positive and then makes its way to the negative and then turns and becomes positive again. So that's what I would guess. And it could have some kind of coefficient or linear term on that, which makes it a little bit harder for us to find, but that would be my guess on that. I can go and look it up in my notes because I did write a problem there that should have worked. Okay, last topic here is composition with graphs. Now, I had to make sure that I clarified that function f is the one in blue and g is the one in red, and you would need some kind of clarification for that. It will be the same on your practice set. So if you're wondering, this is going to be same on the practice set in the practice video. Okay, so f of g of 0, we're going to do this the same way we did with the table, except we're using a graph now. So find g of 0 and then use that number to find the value for f. So since g is in red, we are going to look for g of 0. So we're going to look for the what is the value of g when x is 0. So coming over here, I can see it is that location. So that is the point 0, -1. So g of 0 is -1. And now we're going to use that -1 to go and find the value for f. So coming over here, I'll switch over to blue. We'll come over to x is -1. And then we come up here and find the value for f, and that appears to be the point -1, 3, and so the value would be 3. So f of g of 0 would be 3. Now, I wrote at the bottom of this slide, this kind of problem is not common, and now that you've seen me work it out, it's probably kind of obvious why it's not that common, because there's a lot of values for which this would not work. You would not be able to do this with decimal values, which you could if we had the equations for it. But it is a good exercise in just remembering how we interpret the graphs for this kind of problem. All right, so that brings us to our final slide. Don't forget to give this video a quick thumbs up if you found it helpful. Subscribe to be notified of more math content. Drop a comment, question, or request below. I would like you to request to do the table problem again. And check out the practice set or the many other videos on the channel, and I will make sure that I link the practice set below for you. And I hope to see you in a future video.